Q6736-1. What airspeed indicator marking identifies the maximum structural cruising speed of an aircraft? A. Red radial line. B. Upper limit of the green arc. C. Upper limit of the yellow arc. The correct answer is B. The airspeed indicator in an aircraft provides pilots with information about the aircraft's speed through the air. It typically has different color-coded arcs or markings to indicate various airspeed ranges and limitations. The green arc on the airspeed indicator represents the normal operating range of the aircraft. It indicates the airspeed range within which the aircraft can be safely operated under normal flight conditions. The lower limit of the green arc represents the stall speed, while the upper limit of the green arc represents the maximum structural cruising speed. The maximum structural cruising speed, also known as VNO, is the highest speed at which an aircraft can be safely flown without exceeding its structural limitations. This speed takes into account factors such as aerodynamic stress, control effectiveness, and structural integrity. The upper limit of the green arc on the airspeed indicator is specifically marked to indicate the maximum structural cruising speed. It serves as a visual reference for pilots to ensure they do not exceed this speed during normal operations. By observing the airspeed indicator, pilots can monitor their airspeed and ensure they stay within the safe operating range of the aircraft. If the airspeed approaches or exceeds the upper limit of the green arc, it indicates that the aircraft is approaching its maximum structural cruising speed, and the pilot should reduce power or adjust the aircraft's configuration to avoid exceeding this limit. It's important for pilots to be aware of and respect the maximum structural cruising speed to prevent potential damage or structural failure of the aircraft. 6739. Which airspeed is identified by color coding on an airspeed indicator? A. Design maneuvering speed. B. Maximum structural cruising speed. C. Maximum gear operation or extended speed. The correct answer is B. The airspeed indicator in an aircraft often includes color-coded markings or arcs to provide pilots with visual references for different airspeed limitations and ranges. These color-coded markings assist pilots in quickly identifying specific airspeeds during flight. The maximum structural cruising speed, also known as VNO, is the highest speed at which an aircraft can be safely flown without exceeding its structural limitations. This speed takes into account factors such as aerodynamic stress, control effectiveness, and structural integrity. On the airspeed indicator, the maximum structural cruising speed is typically represented by a specific color-coded range. This color coding serves as a visual reference to inform pilots that they should not exceed this speed during normal operations. 6740. What is an important airspeed limitation not color-coded on airspeed indicators? A. Maneuvering speed. B. Never exceed speed. C. Maximum flaps extended speed. The correct answer is A. Airspeed indicators in aircraft often have color-coded markings or arcs to indicate specific airspeed limitations and ranges. These color-coded markings serve as visual references for pilots to quickly identify critical airspeeds during flight. However, not all important airspeed limitations are color-coded on airspeed indicators. One such important limitation is the maneuvering speed, also known as Virginia maneuvering speed, is the maximum speed at which an aircraft can be safely maneuvered or subjected to full control inputs, such as abrupt control movements, without exceeding its structural limits. It represents the airspeed at which the aircraft can handle the maximum aerodynamic loads associated with maneuvers. Unlike other airspeed limitations that are often color-coded, maneuvering speed is typically not represented by a specific color-coded range on the airspeed indicator. Instead, it is usually indicated by a single numerical value or a placard inside the cockpit. The reason maneuvering speed is not color-coded on the airspeed indicator is that it is specific to each aircraft and can vary based on factors such as weight, configuration, and atmospheric conditions. Therefore, it is more practical to provide a specific numerical value or placard inside the cockpit to indicate the maneuvering speed for a particular aircraft. Pilots must be aware of the specific maneuvering speed for their aircraft and adhere to it during flight. Exceeding the maneuvering speed can subject the aircraft to excessive aerodynamic loads, which may result in structural damage or failure. 6682. A possible result of using the emergency alternate source of static pressure inside the cabin of a pressurized airplane is the A. Airspeed indicator may indicate less than normal. B. Altimeter may indicate an altitude lower than the actual altitude being flown. C. Altimeter may indicate an altitude higher than the actual altitude being flown. The correct answer is C. In a pressurized airplane, the static pressure needed for accurate altitude indications is typically obtained from static ports located on the exterior of the aircraft. However, there are situations where it may be necessary to use an emergency alternate source of static pressure inside the cabin. The emergency alternate source of static pressure is often used when there is a failure or blockage in the normal static pressure system, such as when the static ports are obstructed or damaged. This alternate source may involve opening a static vent or using a static port located inside the cabin, which is not exposed to the external airflow. The altimeter works based on the principle that as an aircraft climbs, the atmospheric pressure decreases. The altimeter measures this pressure and converts it into an altitude reading. When the normal static pressure system is functioning correctly, the altimeter accurately reflects the change in atmospheric pressure and provides accurate altitude indications. However, when the emergency alternate source of static pressure is used, it introduces a different reference point for static pressure. Inside the cabin, the pressure may not be directly influenced by the changing atmospheric conditions outside the aircraft. As a result, the altimeter may indicate a higher altitude than the actual altitude being flown. This discrepancy occurs because the altimeter is still measuring the pressure inside the cabin, which may not decrease at the same rate as the atmospheric pressure outside the aircraft during a climb. Consequently, the altimeter indicates a higher altitude than the true altitude. It's important for pilots to be aware of this potential error and take it into account when relying on altitude indications while using the emergency alternate source of static pressure. They may need to cross-reference altitude information with other sources, such as GPS or radio altitude callouts, to obtain a more accurate picture of their actual altitude. 6737. What does the lower limit of the white arc on an airspeed indicator represent? A. Minimum controllable airspeed with flaps extended. B. Power off stall speed in a landing configuration. C. Power off stall speed in a specified configuration. The correct answer is B. The white arc on an airspeed indicator is typically used to indicate the normal operating range of the aircraft's flaps. It represents the range of airspeeds within which it is safe and appropriate to extend or retract the flaps during different phases of flight. Within the white arc, there are usually additional markings that provide specific information about airspeeds associated with certain configurations or maneuvers. One of these markings is the lower limit of the white arc, which has significance related to the aircraft's stall speed. Stall speed refers to the minimum airspeed at which an aircraft can maintain controlled flight. It varies depending on factors such as aircraft weight, configuration, and atmospheric conditions. The lower limit of the white arc represents the power-off stall speed in a landing configuration. A landing configuration typically refers to a specific combination of factors, including the deployment of flaps and other devices that increase lift and drag during landing. The power-off stall speed in this specific configuration is the airspeed at which the aircraft will stall when the throttle or power is reduced to idle. By indicating the power-off stall speed in a landing configuration, the lower limit of the white arc serves as a visual reference for pilots during approach and landing. It helps them ensure that they maintain an airspeed above the stall speed while operating with flaps extended in a landing configuration. Pilots must avoid flying below the power-off stall speed in a landing configuration to prevent an inadvertent stall, which can lead to a loss of control and a potential crash during critical phases of flight, such as approach and landing.